Hi, this is the second video for the Scramble board set series that I'm going to do. Excuse me. In the last video we tried to read back some data from the ROMs on these Scramble boards, if you can remember, and as a result it was coming back with data that seemed to be in blocks of 4, but it didn't tally up with what the ROM data should be. So in the last video I came to the conclusion there was obviously some issue with the buffers that feed the data bus from the microprocessor into the Scramble board. So there could be something wrong with that. There could also be something else wrong, but I think the first thing we're going to look at in this video is we're going to check the chips all around the Z80 processor. Now to do this I've decided to do something slightly different. Instead of going in and using some of the other tools in the tester, I'm going to use the ADT function, which is the chip tester. And what we're going to do is we're going to check the two buffer chips, which are 8216s, and they are quad bidirectional buffers that feed the data bus into the rest of the Scramble system. There's also on the address lines, I've noticed, if you look at the circuit diagrams, there's actually 3 LS367 buffer chips as well, which feed the data, feed the addresses out of the microprocessor and go again into the Scramble system. So we could have a problem with any of those, and also there could be problems with the select lines to the ROMs. There could be all sorts of things. So I think the first thing we'll do is we'll check some of the chips with the ADT. So the first thing I'm going to do here is go into the ADT. Now I'm getting two windows up. Excuse me. The reason I'm getting two windows is because I'm running it on an external monitor, and because of that you will get all the different windows popping up. If you're using it on the LCD screen that's built in, you'll only have one window at a time, but it'll be overlapping, so you won't only see one at a time. So what we'll do is we'll simulate that by just putting that over the top of that one, so we don't confuse things. Now the first chips I'm going to do are the 8216s. Now I've actually just taught this how to do it, and I'll show you how to do that in another video sometime. So we'll type in 8216, which is the buffer chips on the data bus. They're actually 16 pins, so I'll put in 16 pins, and I will show you clipping them on so you can see what I'm actually doing. Now again, excuse all the mess. Right, there we go. Now because the ADT works by seeing the chip in an active state, if we just had the pod hooked up for you take the microprocessor and just put the pod in, the chips, particularly these buffer chips, will be sitting in one state only. They won't change. So what I've had to do is put the Z80 back in for the moment, unplugged my tester from that socket, put the Z80 back in. So really we've got the board powered up and it's now running, but obviously it's not working because the processor is obviously looping around or getting stuck. But the important thing about it is that the data bus will be active, which means the two chips which we're going to test are these two here. They should be active. So what I'm going to do is I'm going to get my test clip, and on the test clip there's pin 1 is marked. It could be marked different ways, but basically that is pin 1. So the opposite end is the ground pin. So if it's a 14 pin, that will be pin 7. It will be pin 8 if it's 16 pin. But the important thing, that pin must be actually on the ground pin of the chip. So it doesn't matter if these other pins overlap and don't go anywhere. The important thing is it must start on the ground pin. So we'll put it onto the first one. The board is actually powered up at the moment, so it doesn't matter if it's clipped on when it's not powered up or powered up at all. But you have to have the board powered up to test, of course. So that's the first chip, and what we'll do is, if you can see that, it's again, my camera's a bit iffy. We'll do a test on that, and it tells me it's passed. As you can see, we have 3 blocks. These ones here are red, which indicates these signals were high, and the rest are there. We can also do it again, and you get a different state, and again it's passed. If I do a stuck check, which will look for stuck pins, it will go through. The pins that are not stuck will go black, and any stuck pins will show up as green or red depending on what state they're stuck in. Now this looks to me like this chip's alright, because obviously all the pins have all gone black. 5 volt and ground are not tested, so the net result of this is that's it, it's past that. So I would say there are no stuck pins, so that chip, that buffer chip, looks good to me. So without moving the camera, I'm going to do, hang on, I'll do it a little bit so we can get it a bit clearer. I'm going to put it onto the next chip. I won't move the camera, but it's basically exactly the same but on the next chip. and that's it on the next 8216. There are only 2 of these on the board, so we'll go again test, and again that one's passed. We'll do it a couple of times. Oh well, that one's failed, but before we condemn it, it could be that that state has not been stored in the tester. So I think the best thing to do is we'll just ignore that for the moment, and we'll do a stuck check and see what happens, because what we're looking for is stuck pins. Well, it certainly seems to be, oh well there you go, they've all cleared. It looked to me like there was going to be 2 and 4, but 2 and 4 have cleared. Sometimes they don't always clear straight away, it depends what state the chip is in. So it's looking for pins that change state and then they go black. So if they change state and go black, you know that pin is working somehow or other. So from that, it does look like the data bus buffers are actually alright, which is a good thing too, because I haven't got any, so that's quite handy. So the next thing we're going to do is we're going to check the address buses. Now there's 3 LS367s which link A0 to A15, and also the read and the write lines go through them as well, and they just go through basically buffers into the rest of the circuit, and I'll show you those. Where are we? So there you can see I've actually got the test clip on the second 8216, which is that one. So I'll take it off. So those 2 chips, which are the data bus buffers, appear to be fine. Processor there, buffers there. So the ones we're looking for now, and I've already checked this on the schematic, are these chips here. Now these 3 chips here, move that down a bit, you can see these are LS367s, and they are buffers for the address bus. So we'll go on to the first one again, clip it straight on like so, and what we'll have to do here is, whoops, move this up a bit, change the chip. So instead of an 8216, we're going to go for a 74 LS367. Important to type it in capitals because this is case sensitive. So make sure I generally store all the chips as capitals, but you could store them as lowercase, but then you'd obviously need to relearn them all because it won't look for the same file. So an LS367, 16 pins again, we'll test that. Looks good, passed. This one actually has got a GIF file stored in it, so as a result of that it's displaying the internals of the chip, and you can see pin 1 and pin 15 are the enable pins, active low, so when they're low these buffers effectively just feed the data straight through. So you can see we should be looking for both of those green because it's a single buffer, green, those both reds because high in, high out, etc. Again, what we'll do is we'll do a stuck check, see what happens with that. They all look good, so they've all changed state, but the only ones that haven't changed state is 1 and 15. If you go to the circuit diagram, pins 1 and 15 are actually tied to ground, so the buffers are permanently enabled. So that is fine because it's showing me up those 2 are grounded and the rest have all gone black, which indicates the states have all changed. So that chip's good. I'm going to now put it on to the next one. We'll just do it with all 3 of them and see what happens. Okay, so I'm on the next one. I'm going to do the same again. It looks like passed. You can do it a couple of times if you want. As you can see, each time you'll get a different state sometimes. I'll do a stuck check again. We'll run this one through and see what this one shows up. It's looking good so far, I have to say. There you go. All the pins, yet again, have changed state. So without probing too much with these 2 chips, it would appear to me that these 2 chips are actually working. So we'll go on to the 3rd chip, which is another LS367. Now this one is actually going to be an interesting one because this is actually IC2B, and the important reason this is interesting